Hi, this is Benjamin, founder of Farmagain. So today we are near Kambam Lower Camp. Right behind us is the Western Ghats. So this is once again a special farm, and I'll talk about what is special about this farm a little later. And this is Mr. Jayachandran, who is the owner of this farm.
Yes.
Hello, sir. How are you?
Very fine.
Okay. We have in the past posted a lot of videos. We talk about something that is useful to the farmers at times, and sometimes we also post videos where we talk about Growtron and how it benefits a farm. So the common question also had been, are all the Growtron installations 100% picture perfect? Has there never been an issue? So there are sometimes mistakes that happen. So especially when the mistakes are at the design side of the irrigation, it could impact the overall irrigation to a farm. So this farm has one such design issue. So we're going to talk about that in detail, and we're also going to talk about how to avoid this, so that farmers who are planning for a new irrigation or new automation system can benefit from this, understand what impacts the irrigation positively and negatively, and plan their irrigation accordingly. So that's the purpose of this video. So far the coconut farms that we have seen are all with inline laterals, and specifically we go with pressure compensated drip lines. And this farm is an exception in that sense, because you can see that the irrigation here happens through taps, and the ring structure is slightly away from the trunk. Most of the tap farms, you can see the rings very close to the trunk, but here it is little away from the trunk, which helps because it is closer to the roots. But the thing about this tap system is that the water gulps out as against drip, where it actually drips slowly, which means it requires a reasonable amount of pressure for water to come out and fill this ring at a short span of time. And if they are able to do that once in 3 days or 4 days of irrigation, should probably suffice to maintain the soil with reasonable amount of moisture. And this farm also has cocoa as intercrop. Generally, this region is suitable for cocoa and nutmeg. And this farmer, Mr. Jayachandran, is quite creative. So what he has done is, between every 2 coconut trees, he has planted 1 cocoa tree, and he uses the small tap. This is also tap, but it's a 6 mm micro tube, and to the end he has attached a small tap. So the reason this is small versus the coconut being bigger is because for coconut you'll have to cover a large area. Moisture has to go to a large area because the root zone is larger. And for cocoa, you basically have a shorter area to be covered, therefore a smaller tap is sufficient. So that's a thought process the farmer had in his own design of this irrigation system. So this plant, cocoa, and this coconut, rather this whole plot, gets its water through a valve that is right here, right next to us. So this is a valve. Now, where does this valve get its water source from? From the tank right behind us. So this is a valve structure to the plot, the plot where we are standing. This is a valve that carries water to this. So the coconut and cocoa that we saw are right behind me now. And the source of water to this, as I showed, is actually this tank. Now, these taps to get enough water, let's say there are some n number of trees, and all of them together, let's assume, requires about 20,000 liters of water. The few parameters that we need to keep in mind: one, the pipe itself should have that carrying capacity. Let's say if it is 20,000 liters per hour, it should have that much of carrying capacity. Number two, now I talked about a challenge in this farm. Now I'm going to explain the challenge. People who are specifically into gravity based irrigation, I really request them to watch this very carefully, and even for other people the information will be quite useful. So normally you have this ball valve, and this ball valve, how it opens when you now it is in closed position. So the ball that is inside this valve actually crosses this and closes the water supply. When you open this, what happens is the ball turns, and it is absolutely hollow inside, which means the inner diameter of the pipe and the inner diameter of the valve when it is open are both same. So the water in is equivalent to water out. But This solenoid valve or any solenoid valve does not work that way. What happens with the solenoid valve is that there is no ball to move inside. Therefore, there is a diaphragm, and the diaphragm moves upwards, and the water that gets into this valve goes through the diaphragm, lifts it, and through an inverted V shape comes out of this valve, which means there needs to be some pressure to push the diaphragm upwards and keep it up always so that the water can flow through easily. Now there is a minimum pressure required to lift the diaphragm up, and also there is a pressure required to keep it up in that up position so that the water can flow through this. So this particular valve you are seeing here is rated for about 0.5 bar pressure. So which means it can open the diaphragm only at about 0.5 bar pressure. But then for it to efficiently push water out, that means in the quantity of water in equals the quantity of water out. If you want to get to that situation, this valve requires at least 1 bar pressure. But the distance or the vertical height between this valve and this tank is just about a meter or a little more than a meter, right? So why does that matter? This is where the actual science is. Every 10 meters of vertical height increases the pressure by 1 bar. So if the water tank was situated about 10 meters above this spot, this valve would have seen a pressure of about 1 bar. But unfortunately, this is only about a meter and a half tall from this place. So you can extrapolate that. 10 meters equivalent to 1 bar pressure, 20 meters equivalent to 2 bar pressure, so on and so forth. So now the system has been installed, but then there are a couple of valves in this farm that are very, very close to this water tank. Therefore, it does not get sufficient pressure for it to lift its diaphragm and keep the diaphragm open to make sure the irrigation is smooth. So this is the problem, the real challenge that I wanted to brief is this. Now, how do you solve this? Is there a solution first of all? Yes, there is. Like I said, the diaphragm needs a pressure to open. So what is the pressure required? About 1.5 would be the ideal pressure with which this can give pretty much full flow. Water in can be equal to water out. But then if you want to create 1.5 bar pressure, there are a few ways. One, take the tank upwards about 15 meters. Is it possible? No. So what is the other option? The other option is to calculate the right pump, which could give 1.5 bar pressure to the inlet of this pump. So if the water flow is about, let's say, 20,000 liters, so for 20,000 liters, to create 1.5 bar or 2 bar pressure at the inlet of the valve, what is a correct pump to go with? There are mathematics involved, some calculations involved, and based on the calculations, we derived that it should be around 2 to 3 HP rated pump, which could give that kind of a pressure. With that, you will be able to operate almost all the valves that are very next to this tank, and also the valves that are far away from this, which are deeper from this tank, will also work. Just to summarize, any agricultural irrigation system needs to have its pressure. I've heard a lot of people say that I did drip irrigation, but then I pulled it off. I am now doing a flood irrigation. So you won't have to get to that situation if one gave enough importance to the pressure calculations of each place. For instance, every bend and every tee has its own pressure loss, right? One needs to take into consideration all the pressure losses possible in this zone of this farm to even derive the input pressure that is actually required, and accordingly you'll have to calculate the pump unit. But generally what happens is the pump is already there. People talk in terms of HP. Generally that's what we hear, 5 HP, 10 HP, 7.5 HP. But really what we should talk about is not HP. It's about what is the pressure, or in other words, how many liters per hour can this pump push at what meters head. So that's the real language one should understand. So what is meters head? Simply put, the number of meters the pump can vertically push water out at a given liters per hour of output, right? So as long as we understand how to select a pump, what is the necessary head in meters that I need to think about, and what is the necessary flow rate in liters per hour. If I know these two parameters, I can pretty much do a perfect calculation of the right pressure and the right pump for that pressure. And if you take care of these two, the irrigation can be absolutely peaceful. So we talked about the pressure related issues in irrigation system. So my recommendation to farmers who are going in for fresh irrigation system, please do take into account the pressure calculations, the choice of the right pump based on the pressure you need. Please give adequate importance to getting those things right. And if you are able to get those right, and I'm sure your irrigation will be a very, very smooth journey. And coming back to this farm, as I started off with in this interview, we have pressure related issues in this farm because of the elevation, very low elevation from the water pond to this valve. Now, between Mr. Jayachandran and me, we have discussed several options. So, why don't you explain the way forward next for us to be able to correct these pressure issues?
This farm is a totally off-grid farm where there is no electricity. So what basically structure we had earlier was or is we have a head water tank on a very elevated place, and from there on water on gravity is being distributed right across, and we have the regular tap systems for these coconut trees where the flow is high and we irrigate for about 1 hour's time. Now what happened is when we installed the new Growtron automation, we've just found out that the pressure was less and the water flow was less. So that is the issue we were having of the more time we needed to spend on irrigation. We didn't actually calculate the pressure, exact pressure required for each in this method. So that's why we actually had this challenge, and now me and Mr. Benjamin have come up with a solution. We're actually taking some steps like installing a solar pump, 1 or 2 HP or whatever the design team recommends, with a filter, and we're going to go for inline irrigation method, which will also cover the whole tree, around the tree, and we'll get adequate pressure for these walls.
So usually when we automate any farm, I mean, like I said in the previous video, we've done about 1,500 acres plus of coconuts farm alone. But any farm we go to, first we start with the hydraulic design. The irrigation design engineer actually goes to the field and they start with basic design. But here, because there is tap irrigation and the decision at that point in time was to continue with the tap irrigation, the design team actually did not visit this farm. And if had they visited, we would have known the potential pressure issue right then. We could have taken corrective step even before installing Growtron. So that was a real miss. So now, like you said, we're going to change this to drip irrigation and pump is going to come. But before all of that, our hydraulic engineers will visit. They'll take the measurement, do the computer simulation, and after the simulation, then we will be able to conclude what pump you need, what is the pressure required, all of that we will know. So once we get that right, we'll be able to correct the irrigation, and similarly the fertigation is also going to come in the next phase. So trees like this, hybrid, any hybrid tree, and this particularly DJ, has a potential of about 250 nuts, coconut, mature nuts, and about 400 tender coconuts. But again, the only way you can even dream of getting to those numbers is by ensuring the right fertigation. The nutrition management plays a key role. So like we always say, there are two things. One is maintain the right moisture. Number two, maintain the right nutrition. If you can do these two, subject to of course other natural conditions, you can dream to get to the genetic capacity of this plant. So in this form, we have these pressure issues. We now have the way forward plan, and once that is corrected with the nutrition management, these are now about 5 years old trees. I think in about a year and a half, we should somewhere be able to go very close to the genetic potential of these trees.
Irrigating land is being done by men as very traditional ways, and because of their inefficiencies, correct amount of water does not go to the plants. For example, they either over irrigate or under irrigate. So to actually have a correct schedule of exact timing, and you also can monitor how much of water you actually providing to the plant by your online app. You can control the app. You know exactly what kind of temperature with the sensors they give. You know exactly which land is dry. You can irrigate accordingly. The second is I mean the land is irrigated in the night, so usually nobody comes, no manpower comes and irrigates in the night. We have night irrigation facility. I mean we irrigate in the night, which is the apt time for irrigation between 6 to 10, 6 to 12, 6 to even night 1, 2 o'clock. It's all automated, and we have and these are I had taken a couple of quotations from other companies as well, but they had the whole farm had wires running all over the place and was very hard to maintain, I thought. So, but these are really wire free, and they are, as I mentioned earlier, it's an off grid, so we have no electricity here. It's all with the solar panels, so it's actually saved my purpose. We have some issues with the pressure, which we are going to sort it out now by including some extra pump, and it's been a great travel, good service. Even night 10 o'clock I can call the tech people for any advice or any solution, and in programming or anything in the app, and they are ready to help.
So as discussed in this farm, to correct the pressure issues, we have worked out a strategy, and that will be executed right now, probably in the next few weeks to months. And by end of this year, end of 2024, we will come back, revisit, and then again shoot a video with the proper pressurized system. So I hope this video was useful, especially the pressure related information that is shared. Please try to apply this in your irrigation projects, and if you find this information useful to somebody else, please do share this with them. And to get notified of these kinds of informative videos in the future, please do subscribe. And until we meet again in another video, thank you for watching. Thank you very much. Thank you, sir.